So for solving simultaneous equation in AMF, we typically deal with a pair of linear and non-linear equations. So therefore, we won't be using elimination method and graphical method. So we will actually be using substitution method. So in example 1, we have the first equation x plus 2y equals to 1, and second equation is x squared plus y squared equals to 10. So this is a pair of equation where one of them, which is equation 1, is actually linear, and the second equation is actually quadratic. So we'll be starting from equation 1, which in this case is clearly the one easier to work with. So I'm going to make x a subject. So x equals to 1 minus 2y. I'm going to name this as equation 3. Next, I'm going to substitute equation 3 into equation 2. So replacing the x with 1 minus 2y, I'll get 1 minus 2y whole thing squared plus y squared equals to 10. And then to the next steps will be to expand and simplify. So I'll get 1 minus 4y plus 4y squared plus y squared equals to 10. All right, and next, rearranging and simplifying, I will get 5y squared minus 4y minus 9 equals to 0. So here to solve for the values of y, we have the option of either using quadratic formula, or we can actually factorize and solve. So here I'll just go with factorizing it. You can try to factorize this on your own as a matter of practice, right? So I'll just show the factorized form, which is y plus 1 and 5y minus 9. So y plus 1 times 5y minus 9 equals to 0. So solving this equation, we're going to get y plus 1 equals to 0, or 5y minus 9 equals to 0. That's applying the zero product rule. And then next, y equals to negative 1, or y equals to 9 over 5. So for those who prefer to leave your answer as a mixed number, you can also do that. All right. And but for later on, when we try to solve for the value of x, actually the improper fraction will be easier for us to work with. Okay, so next, we have already found the value of y. So next, we will need to find the value of the corresponding value of x. So we'll do this separately. So first of all, I'm going to substitute y equals to negative 1 into equation 3, right? And replacing the value of replacing y with the value we found, which is negative 1. So we'll get 1 minus 2 times of negative 1, and so x equals to 3. All right, and next we will substitute y equals to 9 over 5 into, again, equation 3, and we'll have x equals to 1 minus 2 times of 9 over 5, and that's going to give us negative 2 and 3 over 5. So don't just leave your answer here. You need to conclude this, because you are finding the solution to this pair of simultaneous equations. So there is going to be a value of x and a corresponding value of y. So the first set of answer would be x equals to 3, and correspondingly y equals to negative 1. So the other set of answer will be x equals to negative 2 and 3 over 5. Correspondingly, y equals to 9 over 5, or in this case, we would just leave both the value of x and y as mixed number, just to be consistent. So if you put your value of x as negative 2 and 3 over 5, for consistency, your value of y, just leave it as a mixed number as well.